Welcome to WOW TV. My name is Angel, and I'm here from the Wizards of Wright program. The WOW program is a part of the Educational Outreach Office here at Wright-Patterson Air Force Base. Today you're going to learn something about rocketry and experiment with testing pressure. Are you ready to get started? Let's go. We need to start today by reviewing some things you've already studied. Teachers, please take the next few minutes and have the students go through what they know about the following things: Sir Isaac Newton, Newton's laws of motion, force and thrust, and what they already know about rockets. I'll meet you back here in a few minutes and we'll move forward after that. Okay, now that you've reviewed what you've already studied, let's connect that to today's lesson. In order for a rocket to be launched into space, some kind of force must be used to push it. A force is the push or pull on an object, and thrust is the kind of push that moves a rocket. As you know, two of Newton's laws relate to force and therefore to thrust. Which ones? There's Newton's second law. It shows us the relationship between an object's mass, its acceleration, and force, and Newton's third law. It teaches us that for every action, there is an equal and opposite reaction. Now, when two objects interact, both objects exert a force on each other. The sum of those forces determines whether an object will move or not. For example, when you sit on a chair, you are exerting a force on that chair. Your weight is pushing down on it. But what force causes you to stay seated and not keep moving all the way to the ground? The chair is actually exerting an equal and opposite upward force on your body, which we know because you remain at rest. It is only when two forces are acting in equal and opposite directions that an object will remain at rest. This means that anytime there is any kind of force, there is another force of equal size and strength pushing back against it. When you blow up a balloon, you are filling the balloon with gas particles, oxygen. The oxygen molecules move freely within the balloon and may collide with one another. As you continue to blow it up, more gas is added to the balloon. The number of gas particles in the balloon increases, as well as the number of those collisions. As the number of collisions increase, so does the pressure within the balloon. Newton's third law can help to explain how rockets work. Rockets create a force acting in one direction in order to propel themselves forward. As the rocket accelerates in one direction, a force of the same magnitude is exerted in the opposite direction, pushing the rocket through the air. This force is called thrust. Pressure inside our balloons will serve as the fuel for our rockets today. The pressure inside the balloon becomes greater than the pressure outside of the balloon. When you release the opening of the balloon, gas quickly escapes to equalize that pressure. As the gas is released from the balloon and pushes against the outside air pushes back. The rocket is propelled forward by that opposing force, thrust. Think of being in a pool and pushing off the wall. As you straighten your legs, you push against the wall of the pool. You move forward because the force of the wall pushes back. Let's think about some other things that make an object move. For example, a car, a bat hitting a baseball, or a runner. Can you identify the pairs of equal and opposite force of these movements? Now, let's talk about the activity and tests you're going to run today. You're going to use balloon rockets to test pressure and try to transport cargo while attached to your balloons across a suspended string. You will be using different size balloons in your tests, and as I said, your rockets will be transporting some cargo, maybe in something like this. You'll need to think about how balloon sizes and cargo might affect the speed of the balloon. 3 steps have to be completed before you start testing your rockets. You might want to split the jobs among the members of your group. Task number 1, you need to build a device to safely transport cargo from one area of town to another. The cargo will be attached to your rocket. Task number 2, one end of the string needs to be tied to a chair, thread through a straw, then tied off on the other end to the other chair. Pull the chairs apart until that string is tight. Make sure you are tying the ends of the string to something sturdy, desk to desk or chair to chair, and try to measure about 10 feet for your string. Task number 3, you need to secure the cargo carrier to the straw. I'll meet you back here in a bit and we'll move forward after that. Teachers, let's pause here while the students get into their groups and get everything set up. We'll come back together before they begin to run their tests. At this time, make sure they have the materials they need, as well as the data recording sheets. Okay, you should be ready to test. Here are the steps you'll need to follow. Inflate your balloon. Use a clip to secure the end of the balloon. Tape the balloon to the straw. Add cargo and check for balance. Release the balloon. Discuss your observations with your team and record your results, and then continue testing. Here are a few tips that you will find helpful. Use a balloon pump and the same number of pumps to inflate the balloons to a consistent size. Make sure the string is level for beginning tests. And binder clips or chip clips will help you keep the balloon inflated until you are ready to race. Teachers, I'm turning this all over to you now. You can run the testing as well as have your students discuss the results they observed and recorded. You'll see on their data sheet some suggestions for more tests and different variables. Thanks for joining me today, and thank you so much for using this WOW lesson. Please check out more at our website at wpafbstem.com.